Physicists around the world are waiting to discover fundamental answers at the end of this tunnel. The mystery of black holes and the so-called God particle. But processing that data is a cosmic feat in of itself. Let's take a look.
After this catastrophic failure occurred, the ring and the cooling system were repaired. Now that we're up and running, we're getting a tremendous amount of data.
This is a new regime, and we possibly can get new physics out of it.
The energy that we have to get to where we believe this new physics will for the first time be gotten by the LHC.
You have all of these particles that you want to identify what kind of particles they are, their momentum, their energy, and so you have an enormous amount of data acquisition hardware and software that's required.
We get data from the detector in bits and pixels and disconnected pieces of information. Centers like the OSC with tremendous amount of computing power can put this together and give us a picture, and then we analyze each collision as it comes.
The Ohio Supercomputer Center is a shared resource center, which means that academics in Ohio have access to a central collection of very large computers and large storage that they can use to assist in their research. Our system would be about 10,000 times as large as your average home computer.
It has thousands of central processing units and enormous amounts of storage capacity.
When they're generating data, they will be writing 1.25 gigabytes per second of data over the network to these centers around the world. So that's about 2 CD-ROM drives worth of data every 2 seconds. And so when we were looking at these numbers 10 years ago, they had the model that showed how fast computers would be in 2008 to 2010. They were counting on Moore's law and the increase in computational power year after year. So it would have been nearly impossible to support all of the computing that they would have needed 10 years ago. But today it's much more modest. It took some remarkable foresight on their part.
That's our advantage of being at Ohio State, that we're able to take advantage of this to analyze our data.
The LHC is really a leap into the unknown, going for the underlying symmetries of the universe, and really pushing the edge of mankind's knowledge.
There's a problem in our understanding of fundamental particles. Everyone knows that the electron has a mass. There's something fundamentally wrong with a singularity having a mass associated with it.
There's some idea that the Higgs boson is the magic particle that gives everything mass, and this comes about through its coupling to the particles themselves. How tightly is a particle coupled to the Higgs field?
We've had hints that the Higgs exists, but nobody's ever seen it directly. Higgs is the carrier of this new field, the new force in the universe, and what we're attempting to do is see it. Once confirmed, we have a very nice view of the world. All the fundamental particles are singularities with zero mass, and it's their interaction with the field which gives mass to everything else.
There was a time that our politicians were natural scientists, people like Benjamin Franklin and Thomas Jefferson, and they wanted to understand how nature works.
It's the greatest thing we could ever understand in the world, just how the subatomic world works and how nature and time are put together.
Understanding the fundamental features of the most fundamental forces in nature and being part of this worldwide effort. It's just a blast to be the first to understand something that no one's ever seen before in nature.
There's nothing more fun than that discovery moment when you see something new.
When we return, how our pets are helping our children.